Hey everybody, we're looking at the answer key to this mini quiz from earlier, going through a couple of these problems as quickly as I can, but with some clear explanation, I hope. We have a car traveling horizontally. Okay, it's not going upwards or downwards, it's traveling horizontally on a road. Unfortunately, there's an accident and the car goes off this bridge 3.5 meter off the ground. Investigators determined that the car hit 13 meters away, and we will try to figure out how fast was the car moving at the time it left. Was it speeding? All right. So we know that if something falls due to gravity some distance, we can use this equation to determine how long it took to fall. Oftentimes we're told something falls for a certain amount of time and we figure out the distance, but we can also work in the other direction. As long as you have only one unknown, you can solve an equation, so it can go either direction. So if we plug in the distance that it fell, and then 1/2 AT squared, we can then divide both sides by -5. In this case, it's fallen down -3.5 meters. I then get 3.5 divided by 5, that's 0.7. The square root of 0.7 is, I punched into the calculator here, it's 0.8366. So it's approximately equal to 0.8366. I can then use that, and the definition of velocity as being the distance traveled in the amount of time, that 13 meters of travel in less than a second is going to result in a speed of about 15.53 meters per second. So that's approximately 15.53, and that's meters per second, sneaking it in there. We can then multiply by our conversion factor, multiply by 2.237, I rounded that, and you're going to get about 34.75 miles per hour, so just under the speed limit. Okay, so part A and then part B is take that 15.53 and multiply by 2.237, and that's approximately 34.7 miles, so 34.8 miles per hour. Okay, so that is the first one. Then the second one is, while riding on a Ferris wheel at the Topsfield Fair, child throws a stuffed animal down to the ground. Actually, it should be out to the ground, really, but if she throws it horizontally at 3 meters per second, at the exact moment the Ferris wheel is giving her an upward velocity of 4 meters per second, we can use our vector skills to figure out, and she's 10 meters off the ground, so this distance here is 10 meters. We can figure out how long it will take for the stuffed toy to reach the top of its trajectory. All right, well, if something is going upwards at 4 meters per second, we know that when something is being accelerated due to gravity or whatever, that the velocity it attains after that, with that acceleration, is just v equals at. So we know that if it was to go up to 0, or from 0 to fall down and have that velocity, we can figure out the time. So we have 4 meters per second is going to be equal to then 10 meters per second squared times t. All right, so I can then divide both sides by 10, and if I do that, I get 0.4 seconds is equal to t. All right, so that is less than half a second that it will take for the toy to reach the top of its trajectory. How high is it at that point? All right, well, the distance something falls, if it was at the top falling down, or the distance it takes something to slow down going upwards, but it's a little bit harder to picture, is going to be that distance is equal to 1/2 AT squared. So we know that it's going to be equal to 1/2 then times our 10 for gravity times 0.4 squared. All right, so it's not going to be a great distance, but it's going to be 1/2 of 10 is 5. So it's going to be 5 times 0.4 squared gives us 0.8 of a meter. So it's not going to go up very high. 80 centimeters, 0.8 of a meter. And then it's going to turn and fall the remaining 10 meters down. So how high is it at that point? How long will it take? 0.8 seconds. How high will it be? Whoops, sorry, 0.4 seconds, 0.4 seconds. How high will it be at that point? 10.8 meter high. How long is the stuffed animal in the air in total? Well, once it goes up to the top, now it's going to fall all the way down. How long does it take to fall all that distance? Well, we can do the same equation, only now it's 10.8 meters all the way to the ground at 1/2 AT squared. Okay, that's equal to 1/2 10 NT squared. So again, that's equal to 5t squared. We've done this many, many times. I divide both sides by 5, and then I take the square root. So I type in 10.8, divide by 5, and then I take the square root. I can just raise that to the 0.5 or type it back into a square root. You'll see it's the same thing. And I get that. And that will be the number of seconds it takes to fall down to the ground. So t then is equal to 1.47 seconds. Then plus, that's the t down. I can put a little d there for going down, plus the 0.4 seconds for it to go up, equals 1.87 seconds total time. Okay, so it's really important to know to break these down, find that top point. How long does it take to go up, and then how long does it take to go down? Once you do that, it gets a little bit easier. What is the stuffed animal's velocity at the moment it hits the ground? Well, if it's been falling for 1.47 seconds, it'll have a velocity that's acceleration times time. So 10 times 1.47 is 14.7 meters per second. That's in the downward vector. We know that the outward vector is 3 meters per second. So that would be 14.7. So we would just do Pythagoras to find the total length, 3 squared plus 14.7 squared, and then I could find that angle by doing the inverse tangent. All right, in the interest of time, I'm not going to do that, but that sets it up, and you can give it a try if you want. Okay. 3 now, if a golf ball is hit on the horizontal and it's at a particular angle of 38 degrees, again, it's just about taking that initial vector. How strong is it? It's 50 meters per second. What is the vertical component? It's 50 times the sine, always the sine for the vertical component of 38 degrees. And that's going to give you your VY direction. V in the X direction is going to be 50 times the cosine of 38 degrees. I should do it that way. And I'll type that in a minute. Okay. $50 sine 38, and that's 30.7 meters per second, and that's in the upward direction. And then 50 cosine of 38. Make sure you are in degree mode. 39.4. Oh, 39.4 meters per second. Okay. So that's the vertical and the horizontal components. How long did it take for the golf ball to reach the top of its trajectory? Again, when something is falling due to gravity, the velocity at any moment is the acceleration of gravity for time. So if we know that the upward velocity is 30.7, that to lose that velocity going up and get down to 0 is just going to be the acceleration of gravity times time. If I divide both sides by 10, I'll get t is equal to 3.07 seconds. So just a little bit more than 3 seconds for it to go up. That's part C. How high above the level fairway is it at that point? So again, if we know that something is at the top and falling down, that's the same as if it's at the bottom and in a sense going upwards, being resisted by gravity. So we can just do the distance is 1/2 AT squared. So that's 1/2 of 10 for about the 15th time is 5T squared. In this case, T is 3.07. So I'm going to take that 3.07 and I'm going to square it, and then I'm going to multiply that times 5, and it's going up 47.12 meters. Okay, then the next question is how far did that golf ball travel? Well, if we know that it took 3 seconds, 3.07 seconds to go up, the total time is going to be twice that, is 2 times 3.07 to go up and down, and that equals 6.14 seconds. Okay, so then if you're traveling horizontally at 39.4 meters per second, 39.4 meters per second, and you're timesing that by the length of time that you travel at that rate, that's going to give you the distance times 6.14. Okay, so that times then 39.4 gives you 241.9 meters. So that's how far the golf ball traveled. Okay, at what other angle would the ball have gone the same distance? Well, if it had gone higher at 52 degrees, it would have gone much higher, but come down at the same spot. So that final one, F, is the complement of 38, is 52 degrees, okay? If you were to ask, like, what would the vector be at the end, you could do analysis where you'd have, you know, the downward portion, and you'd still have the horizontal portion, and you could find that final resultant vector. So there are all sorts of other questions like this you can ask. Hope that made some sense. Good luck, everybody.